In this session, you'll hear from Andy Makins at Snoop on how they get to root cause of incidents in their AWS native apps using the Root Cause Explorer solution from Sumo Logic. My name is Bashyam Anant, and I lead product management for advanced analytics at Sumo. A quick introduction about Andy and Snoop. Snoop is a consumer mobile app that provides personalized insights, also known as Snoops, to help consumers pinpoint their biggest money-saving opportunities based on their spending habits and bills. Andy is a 20-year veteran in DevOps. Andy and his team are responsible for architecting, monitoring, and securing Snoop's platform on AWS. It's also with great pleasure, I want to mention that Andy has been our design partner for Root Cause Explorer, this new solution that we launched in August 2020. We truly appreciated Andy's insights in refining our product. On to our outline for today. We will run through 6 troubleshooting concepts that should be super familiar to on-call staff and DevOps engineers. These 6 concepts are embodied in Root Cause Explorer. Andy will then walk us through Snoop's microservices architecture on AWS with a particular focus on flows related to hotspots in their services and infrastructure. Andy will then show us a real example of troubleshooting using Root Cause Explorer. And then after some best practices from Andy, we will wrap up and get ready for the live Q&A. On to our first topic. Imagine you're running a high traffic e-commerce application. A spike in a particular crucial indicator, such as elastic load balancer errors, might be the first sign of trouble. Hopefully you agree that the bigger the spike in a crucial indicator, such as errors, the bigger trouble it implies for you. So that's our first concept. Our second concept is this notion of context and correlation. So again, going back to your example, suppose the e-commerce application relies on elastic load balancers, EC2 instances, and DynamoDB. Even in this example, when you start troubleshooting, it is important to know when an incident happened, which AWS account region the incident happened in, and which application and microservices were affected. In this example, we see spikes in errors along with a whole bunch of other metrics correlated in a short window of time on July 22nd. Our third concept is this idea that connections help pinpoint root cause. In our example, suppose the e-commerce application relies on elastic load balancers, which connect to elastic load balancer target groups that contain EC2 instances that eventually talk to a database. Knowing these connections will help you correlate error spikes at the load balancer level to error spikes in the target group to CPU spikes in the EC2 instances, which are themselves caused by the throttled database requests in this example. Our fourth concept is this idea that early spikes are most closely related to probable root cause. So here the intuition is that the component of service that breaks first is the probable cause. Therefore, sequencing spikes over calendar time is an essential strategy for root cause analysis. Next, this idea of a real root cause. So in our experience, incidents and outages are caused by one or more of the following factors: unplanned load, like you saw in the e-commerce example, bottleneck or saturation events with critical resources, software defects, and lastly, configuration changes. So in this example, one might conclude that throttling of database requests was indeed the root cause that cascaded into EC2 CPU spikes and errors at the ELB level. But that's merely the first level root cause. You still have to explain what caused the DynamoDB instance to get into a state where it was throttled. In this example, an engineer may have changed the provisioned IOPS setting for the DynamoDB table to save on AWS costs. but then that resulted in the unintended consequence that you see on this slide. So again, connecting the dots from the original root cause to the first level root cause, like you see on this slide, is a key strategy as well. Lastly, golden signals are important for root cause analysis. So these golden signals, what we are referring to are things like load, bottleneck, availability, latency, errors, and throughput events. These are important because it helps you understand the flow of causation in root cause analysis. Very roughly, as you see on this slide, when a system is under load, it can lead to either bottleneck events, for example, database throttling, or availability events, for example, a system or a service has gone down. Bottleneck can eventually lead to errors in the connected services. Likewise, lack of availability in one part of the system can increase latency in connected services. Errors in latency eventually lead to a drop in throughput in the connected services. Very shortly, Andy will walk us through a demo of Root Cause Explorer, an AI ops solution that embodies these 6 concepts to accelerate troubleshooting. But first, I want to hand this to Andy to cover Snoop's architecture with a particular focus on probable root cause flows in their environment.
Thanks, Bashyam, and welcome to the Snoop architecture session and the demo. Let's get started. Okay, obviously this is a very simplified Snoop architecture picture just for this demo. Snoop is 100% in AWS. We're going to go through 3 main flows here. If I give you a quick overview of what Snoop does, Snoop connects customers to their banking and credit card data. We then ingest that data and then recommend money-saving ways for those customers on actual transactions. So it might say you've spent X amount of this vendor or this merchant. Please go here or switch here or things like that. So that's what we do. And then the 3 flows we're talking about here. There's that main mobile services flow, which we're going to detail in a minute. There's a OpenWorks flow, which is our open banking partner in the UK, who deal with all the connections to the banks for us, and we just pick up data from them via an API. And then there's also the ingest and analytics flow that we'll go through. In front of all these flows, API gateways, and then behind the API gateways, then microservices based on ECS and Fargate, or Lambda and SQS and DynamoDB pattern. And at the back end, there's Kinesis Firehose for streaming with Lambda and ETL into an RDS Aurora database via RDS. And then once it's in the Aurora database, we then run Snoop AI ML and human intelligence across those transactions and merchant mappings, and then recommend Snoops, these snippets of information that can help consumers save money. And that's how the overall patterns work. Isolation between the services done via SQS and Lambda patterns. Lambda is obviously auto-scaling. We like auto-scaling services. We also like serverless services, hence Fargate and Lambda being used. We don't want to run EC2. So as you can imagine, this is simplified. So this is a tiny part of the overall system. Give you an idea of scale. We've actually got 200 Lambdas plus running all the time. We've got over 10 ECS services at the moment, and we've only been going since April 2020. So we've had a lot of changes very quickly, and we're a small team. So we're looking at tools like these from Sumo Logic to help us concentrate on what we do best, which is building services for customers. So that's our goal with these tools. And just looking at the root cause flows, we've got this import flow, which, as I said, is a hook from OpenWorks saying the transactions are ready to go and collect. We've got the mobile app flow, which is directly in consumer facing. So that's where they look at their transactions, their money management, and also their Snoops for those insights into how they can save money. And then we've got this ingest and analytics flow that the back end is where those Snoops get created and the numbers are crunched. So let's have a look on the demo and look at a real incident that we had. Right, okay, now you can see the AWS observability dashboard, and it shows you each account So we can see dev, test, and prod, and any other accounts we've got in this connected. We can also look at any regions that are connected, and then we can look at the API resources that we're interested in. Snoop MS is mobile services, which we talked about earlier. And this will give us an idea of what we're seeing and how we're seeing it. So if we scroll to the top, we'll see the API requests, and we can compare today against yesterday as well as last week. On any of these dashboards, if you click the three dots on the top right of the panel, you can then do a search in the corresponding metrics or logs. And then we can see in the server-side errors that it's been pretty flat, but then there's been some 50x errors during a certain period of time. And we can then investigate those a bit closely by looking at the entities events of interest. Okay, and that gives us that view of what else is happening and anything else that we need to look at. So each bubble on this represents a difference and a difference to what we've deemed as normal, the tools deemed as normal. Okay, so the y-axis, the higher on the y-axis it is, the bigger percentage difference to normal, and the colors are basically there to show you, what are errors, what are latency, and it's good that it groups them all together here so you can see if there's latency and errors in the same place. We can see that we've got some 504 errors, and we've also got some latency at the time that we thought we had an issue. We can click on them and we'll see the drift from normal, as well as any period of time that they started and ended, and any difference from normal. And also what entity and what resource it was within AWS. We can then delve deeper by using the root cause explorer. Yeah. And the first thing you'll see when you click on root cause explorer is that the information, the context for the account is still prod. The region information that was already selected has been passed over. The context on the entity has been passed over. So it's still the mobile services API gateway. So we can select the time and the graph at the bottom, and then zoom in. It'll then show us that there looks like there's been a long-running Dynamo latency issue. Yeah, and we've seen that spike, so we know that something's happened there. We need to investigate what it was. Yeah, it was for it's for the prod transactions table, which makes sense because we're importing transactions. We can then look at the metrics and see that latency request, what happened to it, and we could delve in deeper on the metrics if we wanted by hitting the dots. But what we're going to do is delve in using Root Cause Explorer. And the top contributing entities panels, they group things together so that you can see what else has affected stuff. So we know we had a DynamoDB problem with the transactions table. Yeah, we know it might be caused by throttling. We know that it looks like that's then caused the latency issue. Yeah, on the MS API gateway. And then looking at the errors at around the same time, we can then see that the mobile services API gateway has then started getting errors about 10 minutes after the initial DynamoDB problem. So we now need to work out why. Yeah, so we can look at the related entities. Yeah, and we can look at what happened to Dynamo. Yeah, and we're using on-demand Dynamo. Yeah, so we were expecting it to scale for us and not have any issues. When we click on the graphs, you can see that the time period is already set, so that context is there. It's still the same table. We haven't got to do anything to change it. We can straight away look at any of the dashboards and see the context. So we can see that there's been some throttled read and write requests. We can see what capacity has been consumed at that time, and there's a big spike. And we can also see the throttled read requests at that time as well. So we know, let's recap, we know that DynamoDB looks like it caused an initial issue. That was our first root cause. We know that it was latent, and now we're trying to find out why the auto scaling didn't kick in or has kicked in and we missed it. So we need to delve a little bit deeper into the next layer, which is mostly going to be the logs. So we can go back to the root cause explorer. We can look at the events. We know for a fact that the context has been taken over like it has on all the other dashboards. So in the events dashboard, we can see that it's still the transaction table. We haven't got to change anything. It's kept that context. We can look at all the events on the tables. And we know from the AWS docs that DynamoDB should provide an event name of update table events when it's searching for new IOPS, so scaling out the DynamoDB. So we're looking for those in these events. The easiest way to see these is to look at a search. Yeah. So we know that there's lots of events happening on this transactions table. Yeah. We use a classic tool in Sumo Logic, and that's LogReduce, to see where those update table events have gone and if there's been any. So we're searching. Yeah. So LogReduce has told us exactly what's happened in the time period. We haven't got to change anything. We know that it's the right time period. Yeah. And we can see from here there's not been any update table. Yeah, and that's one of the things you can see from this really quickly is you can see where you think you should see something that you're expecting. Yeah, it's bubbled up all the information. You then drill down and you can get to the logs really easily and see what's happening. Yeah, so where are we now? So we thought that it's going to scale up. It hasn't. And we now need to investigate why. Yeah, so as again, recap, DynamoDB had latency. That caused issues with the API gateway for mobile services being latent. That then had a problem with errors on the API gateway. And now we know that update table hasn't been in the event logs. We know that, okay, so auto scaling from Amazon hasn't worked. Yeah. So that is now our root cause to check. Yeah. So we realize that it hasn't kicked in. Now we need to understand why. So since this has happened, yeah, we've done a few things. Yeah, we've looked at auto scaling. We've looked at the way we do the transaction imports, and we're looking at changing that to a more of an on-demand model rather than getting hit for a lot of customer transactions at the same time. We've also looked at swapping to a provision model for DynamoDB for the transactions table, because the API for DynamoDB can't scale quick enough for the amount of transactions we're getting. So those things are, you know, what we're trying to do here. To summarize what we've seen in this demo, we've seen that we can gain 360-degree visibility from our AWS observability dashboards for AWS infrastructure, and we can drill into one particular symptom at a specific time. We can then triage an incident using Root Cause Explorer, which helps us to correlate multiple signals on multiple resources to find the first level root cause, in our case, DynamoDB latency, and then can help us delve into the logs to find any other root causes. Right, now onto the best practices that we've learned using this new root cause exploration tool. First things, best practices. So usually we can see that, you know, errors and latency events are the first cause of most issues. Okay, so they're the things we focus on. They're the things we use the Root Cause Explorer for first, and then that then lets us delve into the detail. Yeah, the only thing to say is context. Yeah, Root Cause Explorer is really good, and AWS observability is really good, but you do need to understand the application behind it. Yeah, so you do need to talk to your developers as you'd expect, and you do need to know what should it be doing, what are the flows, how does it connect. Okay, and then you can use the root cause analysis on top of that to work out what is normal. Yeah, then we got proactive versus reactive. Yeah, we can see from the demo we've done. Yeah, we can see where slow services are. We can see where things aren't connecting properly. Yeah, and then what the best thing is we can see what's normal. It's really hard to see what's normal across AWS, especially when there's a lot of services and moving parts, as everyone knows, and in cloud in general, it's really hard to see that. Measuring success-wise, we've used it a lot. Yeah, and we've enjoyed using it. It's shown us stuff that we haven't seen and we couldn't see just from looking at the logs alone or the metrics dashboards alone. So I think the best thing is time saving. Yeah, we're using AWS observability now as our go-to tool. Yeah, we've got rid of a lot of the older Sumo dashboards for like RDS and things like that and ECS, and we're now using just observability to go through everything. Yeah, saves a lot of time, a lot of searching across various resources. Visibility of load and latency, yeah, it's much easier to see where load and latency spikes are hitting and what services are hitting if they're affecting any others. We've not, we've had, various issues. We had issues with RDS serverless, and we took that out, and that was really hard to see because we didn't have AWS observability at the time. We really had to go through it in fine detail, and it took a long time to support it. Allows us to fine tune our alerts. Yeah, so when you know what's normal, it's a hell of a lot easier to see what an outlier is for what's normal. So it immediately shows us what's different from yesterday to today, and it's got that context so we can drill into that and know what's happened, what's different, why we got more errors, etc. And then what we've been using it for is a lot of instant highlighting of 504 errors, 403 errors, not authorized, that sort of thing, gateway gone away, that sort of thing that we do quite hard to see otherwise. And we can see those, and we can also use it for seeing like DevOps issues. So when we're building a new feature, we use it in dev to see if that feature's hanging together properly. Is it doing what it should do? Is it slow? Is it not connecting right to various other things? Is it getting a 504 across ECS? Between Lambda, is there permissions error? Is there something going wrong? So we're using it for that as well. And then to wrap up, 3 steps to root cause exploration. First one, observe. Use AWS observability. It makes it so much easier than building custom dashboards, looking at custom searches. All doable in Sumo Logic, of course, but it's much easier to use AWS observability. Second thing, diagnose and recover. Use the root cause explorer. Get used to it. Get used to how it works. Get used to drilling through it. It's really useful. And then the last thing is understand the root cause. Delve into the detail of the logs, but don't delve using a needle in a haystack approach. Use the root cause explorer to detail where you need to look, and bubble that information and context around what else has gone wrong at the same time, and then really delve into those logs and see how you can fix it, and immediately go back to your developers with that. You can show them the evidence really quickly. So thanks very much. Thanks for joining us today. We hope you've enjoyed our presentation.